form you want to take this, but what's my next big step going to be? What's the next big step? Set it equal to 0. Yeah, exactly. So let's see here. Let's see, 2x and x should be 3x. Negative 4 minus 2 is negative 6. So it looks like I can factor a 2 out of here. So I should get 8x minus 4, x minus 2.
Is that 3 y?
There's no y's in there. Did I have a... Yeah, sorry about that. As the day wears on, my handwriting gets worse. You see the worst of it here. Anything else, though, that you need clarifying on? Okay, so we'll do that. We'll set it equal to 0. So I have 8x minus 4, x minus 2 equal to 0. And we have to say possible inflection points. Possible at x equals 4 and at x equals 2. Now, how do we know for sure that those, in fact, are going to be in points of inflection? Oh, they're points of inflection only if what happens? What switches? Concavities. Okay, so here we go. The next step then to test is we need to test what happens on either side of 4 and 2. So we can set up a sign chart. So we look at the intervals. And let's see, if this is 2, there's 4. We look at a test value. And so I'm going to test x equals, now I didn't look at the first derivative. This could be a little dangerous because I don't know. I don't know that maybe I have a critical number at 0. But you know what? I'm going to try it anyways, because if 0 fits into the second derivative and makes it positive, then I know that I've got a minimum at that. I'm just looking at where concavity changes. So it doesn't really make much difference. I'll choose a 3 here, and I'll choose a 5 over there. Let's test the second derivative. So let's see. Second derivative, I'm going to pick up my 8 times x minus 4 times x minus 2. So this would be 8 times 0 minus 4 times 0 minus 2. So that's 8 times negative 4 times negative 2. Second derivative, positive or negative? Positive. My conclusion is that the f of x is concave up, looking like that. Try my next one. So that's 8 times negative 1 times 1, my second derivative. Negative. Okay. So my conclusion is that the function is concave down. What do you think about at x equals 2? Is that a point of inflection? Did concavity change? Yes. Okay. So we can say, therefore, f of x has a point of inflection at x equals 2. Well, what about at x equals 4? Now, I've got a problem with this. Do you see the problem? Oops, I chose 4, didn't I? Why did I choose 4? I don't know. I'm going to say that's a big problem because that turns out to be 0, and I don't need that. Okay, so let's see. 8 times 1 times 3. Second derivative is positive. So f of x is concave up. So what do you think at x equals 4? Inflection point? Okay. Okay, that's the type of work then that we need to go through for us to find inflection points. Okay. Let's go on. I think we'll skip that. You guys can do that on your own, can't you? Got enough examples? Okay. Sketch. Have we done this one? Good. Let's do it. Sketch the graph. Soccer team's going to go off and get a victory. Okay. Yes, you want those pieces? While these, everyone's working, go ahead and keep working on that. I counted anything above the, if you had extra credit, anything above the points that came, they could get an A plus on this, were counted as extra points on your extra points on your quiz average. Okay. Let's see. Cheers. Okay. Okay, let's see. Okay, so this curve, piece by piece, you pick up every little piece, you know what you're doing. What I want you to do is, you got to work on this problem again later on. Okay, use the graph shown. Find intervals in which the first derivative is positive. Am I asking you for any different mathematical thinking than the last one? No, I'm not. I'll give you a hint. That's 2, and that's 3, and that's -1. I'll put that as a 0 even. When you tell me intervals, you're going to tell me intervals of the input variable or the output variable. Okay, so you've got a task. Go ahead and work on it.
Just looking at it makes 15 times what it says. Because I was thinking, oh my God.
Okay, Kevin, you have part A. The first derivative is positive. What intervals? From 0 to 2. Okay? Any others from anybody else? Okay, visualize the tangent lines. Okay, the first derivative is negative. Intervals. Katie, again?
-1 to 0 and
Now, you have to imagine this continues on. It's not stopping. Okay, negative infinity to
0.
0 and 2 to infinity. Yeah, well, I have to remember that these are not limited to the screen we see. Okay. The first derivative is, now, you got to be careful here. The first derivative is increasing. Did you think that A and C were saying the same things? They're similar, yes, but they're not saying the same thing. When you looked at the first derivative as positive, you were considering what happens on this. This is f of x. What's happening on f of x? When I say the first derivative is increasing, I'm now having to consider what's happening on the first derivative. So where is the first derivative increasing? Is the first derivative increasing here? The first derivative is a tangent, right? So is the tangent, and we're talking about slope of the tangent, is the slope of the tangent increasing along here? It's negative, right? And eventually the slope becomes 0. Is the first derivative increasing? Is negative 10? It's getting closer to 0. Yeah, it kind of tricks you with that. But negative 10 is less than 0. So if I'm going from, let's say, negative 10 to negative 5 to negative 2 to negative 1 to 0, is the first derivative increasing? Yeah. Okay. Now, let's continue on. Over here, is the first derivative increasing when it goes from 0? But then think about it. What happens at this point? The first derivative is increasing, then all of a sudden, let's say right here the tangent of the slope of the tangent is let's say 5. What happens as I move around this curve? Then it becomes decreasing, doesn't it? Where does it change? Katie?
I have a question. Could it put B times F double?
Yes. Yes, you would. Yes, because what we're doing, we're analyzing the first derivative. Now, let's do it this way. I'm going to change colors here. Would you agree that at 2, the first derivative is 0? So if I put in green the value of the first derivative, I've got a point right there. Where else do I have a point on the input axis for the derivative? At 0. Now, is the first derivative positive or negative here? Are the slopes positive or negative? Negative. So this is actually down here, isn't it? What about here? Positive. The slopes are positive, so I need to be above the input axis here. Something like this. And then what happens here with the slopes? They're negative again, aren't they? That's a bad-looking graph. Okay, but you get the point of it? This is going up and then coming. Let me see if I can take one of those away. Take the whole thing away. Okay. So I've got something like this. Now, where do you think this derivative is going to peak? Have an extrema. I think so too. Now, how far up it goes, I don't know, but it's going to peak there. Why would you say at 1? What else do you think happens at 1? Change in concavity, known as the inflection point. Yeah, so I'm thinking it's going to peak right about there and then come down